Something to Chew On is a podcast devoted to the exploration and discussion of global food systems. It's produced by the Office of Research Development at KState University. I'm Maureen Olewnik, Coordinator of Global Food Systems.
I'm Scott Tanona. I'm a Philosopher of Science.
And I'm John Fabian. I'm a food scientist.
Hello, everyone, and welcome back to the KState University Global Food Systems podcast, Something to Chew On. How do we plan to feed 9.8 billion people by 2050? Increasing the availability of sustainable, arable land through the use of modern robotics could help to expand food production, potentially reducing the destruction of forested land. In this episode of our podcast, we will talk with Dr. Dan Flippo, the Patrick Wilburn Keystone Research Scholar in Biological and Agricultural Engineering at KState, about the work he is doing to mesh state-of-the-art robotic technology with food production to move towards sustainably feeding the world past 2050. Dan, welcome to the podcast. We were looking forward to understanding more about your current research, but before we get into that, can you give us a little background on yourself and how you became interested in this area of study?
So I am actually from Kansas. I grew up near Wichita, a little town called Douglas. Grew up on what's called a hobby farm nowadays. We didn't call it back then, but my dad worked at the post office all day and then came home and farmed. We didn't have too many acres. It was just enough it was more of a side business for him, and he'd like it for it to expand, but it never worked out. He was plagued with machinery problems. And so I have so many memories of broken tractors and that New Holland baler was kind of his bane of his existence. It caused a lot of problems. And so I kind of grew up with this mentality that farmers, they're more machinists, mechanics, and they cuss at machinery and things like that. And so I came to undergrad here at KState in mechanical engineering. And so some of the professors that are still over there taught me. And after that, I had really no interest in going back to grad school. I went to work at Cessna Aircraft in Wichita. Worked there about 8 years. And then me and my wife and first son, we quit that job and went to grad school. While I was at Wichita State, Cessna paid for a master's degree in robotics and mechanical engineering, but emphasis on robotics. And then we went to University of Oklahoma, and I studied under Dr. David Miller, who is well known as far as planetary science, planetary robotics, planetary exploration. So nothing to do with ag really at all up to that point in my education. So I did a lot of wheel to soil interaction, traction, specifically with robots, and built a very big test apparatus. And I wanted to teach at KState, actually. So the reason we went to Oklahoma, we went out of state, was the purpose of getting back to KState. And so I learned a lot about just the robotic world and the robotic field, soil interaction. It was regolith, really, not soil. And then after I graduated there was no university jobs, nothing. And I was really set on being in Kansas. And so opening came up at John Deere in Iowa, programming large tractors. And so this is kind of my getting back into the ag world and ag industry. So I worked at John Deere for about 2.5 years, and that's when the KState job came up. And it turned out more of a postdoc for me. I'm kind of introduced to a lot of features and the customer world of ag machinery. I didn't like Iowa. It was really too cold for me. So in 2013, I applied, and we got the job here at KState. Dr. Joe Harner, he's our department head. He had a kind of a vision for robotics and kind of that next phase of agriculture. So he was very intent on getting someone who had a specific interest in robotics. And so I came in 2013, and we've been here since then. I teach ag machinery courses, off-road machinery courses, hydraulics, some mechatronic stuff, engine power transfer. But my research is in robotics. And so specifically small robotics. What I mean by that is like wheelchair-sized robotics. in the ag field. So we've kind of focused on the smaller side just for safety reasons, because we've found that, once a robot is big enough to hurt somebody, then the amount of sensors and technology and complexity goes way up. And so we've kind of focused in on the smaller robotics and to try to stay away from all that complexity. If my robots ran into you, they would just either stop or run over your toe or something like that, but they wouldn't hurt you. So we've been successful. We've been successful with that. We've gotten several grants through USDA, some Corn Commission grant, and some EPSCoR grants and throughout this time here at KState, I've had some really good collaboration with people. Dr. Stephen Welch, he's been kind of a mentor to a lot of us, and he's got some fun stuff going on, and he's always big into dreaming, and so he's on several of my grants. I'm on his EPSCoR grant. Dr. Brian McCormick over in entomology, we've worked a lot with him. He's always fun to come up with crazy ideas. We had some ideas about shooting, lasers at aphids and things. And so he was all about that. He enjoyed that. And so this is where we're at, and right now we're trying to finish several of these big grants we got. One of them is the high sloped hill, where we're trying to increase our arable land by farming on hills that conventional tractors can't go. It just wouldn't be safe. And so we have these smaller wheelchair size tracked vehicles that plant wheat on hills and either let cattle graze on that wheat or harvest it. And so we're working on that. We're working on Dr. AJ Sharda, who's my colleague. He's got an NRI grant, National Robotics Initiative. Both of those are. And we have a robot that looks for aphids on sorghum and using machine learning. And this, when it spots an aphid or thinks it does, it sprays just that one plant. And so we have a spray rig on a 4-wheel robot. And this will save an immense amount of chemical, both for cost for the farmer and the environment. And so I think it kind of brings up a point where these robotics, we're kind of in a new world as far as farming goes. Up until this point, we've progressed. We started with just scattering the seed, then the horses and oxen, and then there was a phase change, that's a Cessna term, aircraft term. Phase change is when you go from one look to another, a big change in design. And so you went to mechanical tractors, and there's a lot of farmers that fought that. Then we had cabs on our farmers, then we had auto steer, then we had bigger and bigger tractors, and we've come at some issues with just making tractors bigger and bigger. And we've done that because of labor shortages and skilled labor shortages. And so we run into problems with the road and transportation, getting those big tractors on the highway, and soil compaction, things like that. So what we're really trying to focus on is these smaller vehicles, and this has allowed us to kind of open up the world and kind of get rid of a lot of assumptions about farming. Really you're just getting the seed in the ground, and then you're taking the yield from that plant. And so how do we do that? We have a small vehicle, so we've had to kind of rethink how to plant. We're rethinking, the options are kind of open right now. We can think about multi-crops in the fields and more environmental conscious farming. One thing that we kind of talk about here is that we're able to do more environmentally responsible agriculture because we're bringing in technology, because we can rethink how we do things with the smaller robots and stuff. That's kind of where we're at. Any questions on?
Yeah, lots of questions. I don't know where to start, really. So I guess I'd like to hear just a little bit more about what you think this opens up. So, you mentioned the phase change, and, each of these new technologies really changed the way agriculture was done, right? And it sometimes changed what was actually grown, changed how it was grown, changed the, economics and the nature of farms. And so, with all the openness of the future that you just talked about, it's hard to say, but I'm curious just about where you think we're heading with all this change. What does it set up for us?
Well, that's a good question. I'm just thinking, right now with my robots, I'm trying to think through how we can redo things. But for instance, I was just having a conversation with Dr. Sharda the other day about, the whole Native American, they do the Three Sisters method where they grow beans, squash, and corn all at the same time. And those three crops help each other. One fights off bugs, the other one gives, the corn gives the beans something to grow on. With these small robots and automation, we can think about multi-crop fields and not just monocrops. And so it kind of, a lot of people, when they think farming, they think it a certain way. And right now, there's a lot of startups with ag robotics. There's tons of them. A lot of bigger companies, like the company I worked for, and even the other two big companies that do ag equipment, they're a little scared of having their tractors being autonomous, and then they do concept vehicles, things like that. But it's a big risk to have a big tractor computer controlled. A risk for the people that are there, if there was a sunbather in the field, which has happened, things like that. So there's a lot that has to happen before I think these big companies are going to really start selling autonomous tractors. But the startups are crazy, and they're mostly smaller vehicles. There are some like mid-tractor size startup companies. But I think it's going to kind of generate this startup level of people coming up with ideas and asking questions like, why do we have to do it this way? And maybe they're not farmers. Maybe they're just either hobby farmers or urban farmers, and why not? I saw a gantry farming thing where it just has like a small bed that you put in your apartment or somewhere, and it has a gantry that plants and that takes care of all the plants and things like that. Where are we going? Yeah, that's an interesting question. I don't see us getting rid of tractors for quite some time. I mean, the amount of power and work that is done in one pass in those tractors on a flat field is amazing. And I think the tractor companies have really come a long way as far as technology and things, and they're expensive too. I think for a long time, these smaller tractors, these smaller robots that we're working on are going to be kind of augmenting either like on high slope hills or farmers that are just get going, that's scalable. If they want to farm more land, they just kind of buy another robot, things like that. But right now we're trying to just get people to rethink, because farmers have the kind of the tendency or reputation of being somewhat stubborn. And so they do things the way their dad did. Data is another one. I mean, there's so much data right now coming off of ag vehicles and fighting over who gets that data. Other companies will say that data is the farmers, but so there's so much data that no one doesn't know what to do with. I mean, we have images of fields, and so right now I think there's going to have to be some people really kicking up the data analysis part of it to try to help farmers make better decisions.
Do you see the initial use of your work on, you mentioned urban farming and that type of thing, and kind of the difficulty in introducing this into the very large scale. Do you see it first being introduced into the smaller urban farming or smaller farming type systems prior to, and then kind of building up from there?
I do. I think people that enjoy the technology, the people that get the iPhones and stuff like that, they'll kind of think this is really cool and start with there. I see a big community doing that. That's why with this grant, we kind of try to focus on sloped hills, because this is not any place where a tractor can go. And so this kind of helps feed the world. A big push, I'm sure you guys have heard the 2050 push where, we have to feed over 9 billion people by 2050. And so this is kind of an industry rally cry. John Deere kind of talked about that a lot. So we have really tried to bring awareness about that as well. And so one way of doing that is opening up the sloped hills that no one's using.
So do you conceive of these as being scalable if a large producer wanted to take them on, rather than having to do I don't know how many passes on a one section field? That there'd be multiple of these units? Is that the?
Yes. It's kind of the scrubbing bubbles technique. Remember that commercial?
Uh-huh. Mm-hmm.
So you'll have a swarm of robots that will work day and night to get the work done. Now, my robots are pretty slow. They make one pass at really
Sure.
slow speeds, but you can have a bunch of them. And so
Okay.
we're going to have to, networking as far as wireless connectivity, in the rural areas and things like that is going to have to be extended quite a bit. So right now, thanks to the bigger tractor companies, we have RTK GPS, which is, very sub-centimeter accuracy GPS. And that's, we have a lot of those stations and stuff. And so we're able to use that, but we're looking at right now, different wireless technologies. Dr. Sharda especially is looking at that, different wireless technologies to get to talk from, inside the canopy of like corn. And so another nice thing about these small robots is that we can be under the canopy of crops. And we're not looking down at the leaves that are healthy. We're looking up and seeing where the bugs are, trying to see where water stress is, and try to get a better health picture of what's going on underneath.
So I was wondering if you could share a little bit more of the details of what has to be done to make these workable. I mean, so we've got some of the promise, right? So we can open up areas like the sloped hills, but it can be more scalable. You can think about doing things differently, right? In terms of, planting multiple crops, and you can reduce the use of pesticides, right? So these all sound super positive, right? So what are the challenges for making it work?
The biggest one I think of right now is how to keep these guys powered and how to service them. What I mean by service is if they're planting, get them seed to plant. If they're harvesting, get that seed away from them. My vehicles are all electric, so how to get batteries to them without them coming back and having to do that. And so we're looking at some different things that actually I don't know if they're going to work or not, but we're looking at UAVs, unmanned aerial vehicles, to be carrying batteries to service and swap on these ground vehicles. And so that's one way of servicing the robot so it can keep working. We're trying to stay away from fossil fuels. We're trying to keep, it all electrical. But the power density for diesel is so much more than a battery. And so it's just a big challenge, and if you have other robots, or UAVs, or other ground robots that are servicing, then you have to have quite a bit of communication between the two. You have to have routing plans, and things get a lot more complicated. And so I kind of see that once you work with multiple robots, them all working together, that's going to be quite a task. And we have some very smart machine learning people working on this, and just getting them power and getting them seed, or getting the yield back from them. And I think that's one of the things that's kind of holding us up right now. And one thing I will say is that one thing we didn't see coming is getting seed in the ground in a no-till situation, like on a hill. My robots weigh about 180 pounds, 200 if you load them down with batteries. So a normal conventional planter, takes at least 300 pounds to push down. And so we tried it. We loaded it down with weight even. And so we've had to think up some different ideas. And so now we're going with a powered tiller planter that actually is more or less a disc with teeth on it. And it spins, I think it's about 240 RPM. And it cuts a furrow through this ground, and then we put seed in it, and then we cover it back up. We just can't press a disc in there like a normal tractor could. So this takes up power. It's not ideal. It's not what we were going for, but we try to go with the simplest possible design, and then kind of, if that doesn't work, we kind of work ourselves up to more complex issues. But those are the biggest things that we run across right now. Is you could have robots that when they run out of juice, they come back and get recharged and then go back out. But for a bigger field, that kind of becomes not a very good solution. So.
What do you see as the major pushbacks that you might get from farmers that have spent 30, 35 years, using different approaches in the mechanics? What do you expect to have to answer to?
Most of them don't believe that this will work. So,
yeah.
And a lot of them, my dad was the same way, kind of, you're linked to the land. That's John Deere's phrase, but they see farming as you're on a tractor, you're out on the field, you know your field.
Bouncing over the furrow.
Yeah. But the thing is, I mean, a lot of these bigger farmers have 5,000-7,000 acres. You know, do they know their field? Is it them on the tractor? Can they really see how their crops are doing? And they can in certain instances. You know, for example, we have this Dr. Char's working on this NRI grant that spots aphids. And so right now, you know, an entomologist, if you call him up, he'll come to a few places in your field and say either, yes, it's bad enough you need to spray, or no, you need to wait a little while. So either spray the whole field or you don't spray enough, you know, and it's just issues like that. And so I think the pushback is people, you know, agriculture, it's a culture. And so people are kind of pushing back against, that's not farming, you know, that's not.
Sure.
And I think I wasn't around when this happened, but talking to my dad, you know, when people went from horses to tractors, it was kind of the same change, same attitude, same, you know, you're working together with your horse to work the land, you know. And then I read somewhere where when cabs come on tractors, people were like, you know, I want to smell the dirt, I want to smell the earth. And the auto steer, you know, it's not me steering, it's just a computer. How is that farming? You know, it's kind of a fight every time. I do see a lot of the younger farmers just really be a lot more open to technology, a lot more able to do that. One thing is UAVs. Now UAVs exploded into the ag market because, you know, farmers, for one, they thought, oh, I don't have to walk as much. I can see my whole field. Is a huge help. And it wasn't really farming. It was more of a help for farming. And so I think maybe they didn't have to justify that they weren't farming anymore, but this is something that helps them. And so one way for us to kind of get in, or not us, but, you know, robotics to get in is kind of scouting. If we have these scouting vehicles that go out, and it's a lot like UAVs that scout over the top, but if they scout underneath, that's kind of, it's not farming, but it's more of a help to the farmer. And I really think farmers are all about help.
I talked to an old rancher actually a few years ago, and we were talking about advances and this and that and the other. And I said, well, give me an example. I said, well, there was a time when a PTO shaft was very high technology, and the farms I was working on. So, you know, what's normal and what's cutting edge continues to evolve. So I think the trick is to be able to survive that first part of the evolution and get some buy-in to it.
Yeah, and tractors themselves have become so complicated, and, you know, that's a lot of different forces at pushing there, you know, emissions and things like that and features. But I don't know how many farmers can actually work on a tractor nowadays. Not like we had to.
Yeah, right.
So the technology is there. They're just still driving now. So I understand the pushback there, and I probably feel the same way if I was a farmer.
Sure.
So we're just trying to help, you know, and we're not taking over farming. We're just trying to help, you know, help spray aphids, help on low tills, you know, get a little more yield.
Right.
Yeah, Dan, you mentioned that you were working with Dr. Wells on some of the activities you're working on. And a minute ago, you talked a bit about working with people on machine learning. You've got specific activities that you're focused on in building these types of things. What other kinds of expertise within the university do you bring in helping to solve some of these problems or work through some of the challenges that you're facing?
Who else do I collaborate with? Kind of.
Yeah.
Yeah. One great thing about my job is that I have such good people around me. Steve Welch is one of them. Brian McCormick, entomology. We have a lot of people in engineering. So Stacy Kalesia, she is in civil engineering. She does a lot of soil sensing for us. Jared Hoback in mechanical engineering. He's we're talking about some ideas with genetic algorithms for tillage tools. Some we work with Terry Griffin, who is a ag economist.
Economist?
Yeah. Then we have, the computer scientists, and they do machine learning, genetic algorithms. Leo Shamir, Bill Shu, Sanjoy Das, he's in electrical engineering. So we will work with most anybody, and that's something I've really enjoyed. I've learned a lot of things. We also have, so our departments, sorry to interrupt you, our department is, we have machinery, which is what I am, and then we have environmental and biological. That's 3 options of our department. Now, we're all very much different, but it's been really fun to work with, let's say the environmental group. One example of that is they're looking for blue-green algae, how to predict that happening on lakes and reservoirs and things. And so we actually just got a grant. We built a kind of a robotic boat that takes sensors at different depths and trying to get data for them to actually put that together to predict a bloom happening. So that's another fun thing. I'm working with these environmental people, and I get to make robotic boats and things like that. So I really love my job. It's a lot of fun.
So before we know it, this will look like the Palouse of the Midwest if you can get the hills farmed.
That's right. Weed everywhere.
Yeah, really.
I remember talking with Steve Welsh about that idea about a year ago, and clearly it's the same thing that you're working on. He was describing exactly what it was you were talking about doing and increasing. I mean, basically what he was explaining to me was that you're increasing the amount of arable land substantially, which makes a lot of sense. So
yeah,
very interesting.
We have to worry about, erosion and things like that with hills. And so,
sure.
It's a concern.
Yeah.
And our robots rolling down the hill uncontrollably. That's another concern.
Do you have any feel for the impact of having worked in the industries you worked in prior to coming to a university setting, how that maybe swayed or impacted or affected the job that you're doing now? Or was it just kind of a building block to get where you are?
Yeah, it's had a lot of impact. So I worked in several different industries, Cessna aircraft. I was just a design engineer for the interiors. And so I learned a lot about how a company works as far as drawings, numbers, engineering changes and getting a drawing released, all that, dealing with, we did all very custom stuff, interiors for these people. And so it was good kind of get a sense of organization. So that's kind of what I brought to, sometimes I teach that. And then right now, I'm also a coach for a BattleBot team, a junior, senior high BattleBot team. And so we use that in the BattleBot team. And then working at John Deere, I learned a lot about, the relevant conventional features of a tractor, a lot of customer feedback, a lot of kind of issues that are going on with the tractors nowadays, especially with emissions and things like that. So they know more about farming than I do. And so they know they have a lot more equipment than I do or can get hold of. But, explaining like for a range gear, what that means, what's going on in that transmission. And so that's been really good to take that. And then also, like I talked about the 2050 kind of cry, I've really brought that to our department and really have made a big deal out of it. And I got that at John Deere. So it's been good. All that to say, it's been really a good experience. I would highly recommend, it got me started late here at KState, late in my life, but I would highly recommend the experience you get from working in industry. And so I would not want to go back to industry, but it was a good experience.
Well, I was wondering, since you just mentioned being back at K-State here, something I didn't ask you when you opened up, but want to ask now. So why so interested in getting to K-State, right? You said that was your goal, right? When you went to get your last degree down in Oklahoma and you left so that you could come back here. So what were you looking for here? Why K-State?
Well, it's nothing more complicated than me just loving Manhattan, loving K-State. I came here from undergrad and fell in love with it. I tried to get a job here in Manhattan, but at that time there wasn't anything. I mean, I think McCall's had a factory or something, but there was nothing much. So I like the ag school. So, and I've always loved KState. And I want to be home. I want to be close to home. I did not enjoy being, Iowa was too far from me. I didn't mind Oklahoma so much. It was warmer. I like that, but
Gotcha.
I don't know. I don't have a better answer than I just like it.
Yeah, that's plenty good of an answer. So then let me ask the flip side of the question about what you brought from industry, which is what's different about working on kinds of things you're working on now in a university setting, right? As opposed to what, you mentioned all the startups working on, robotics and ag, right? What's the difference between, working on maybe things that are, like this or related to this? So you mentioned that a lot of the big companies aren't necessarily going to sort of adopt some of the things that you're talking about right away because they're focused on different things. But what's the difference between working on this kind of stuff in a large established industry versus a startup business versus university setting? Are you exploring different kinds of questions and or different kinds of, pushing the boundary more in the kinds of robotics you're working on? You asking different questions? How would you describe the difference?
Well, it's probably different for different people who are different jobs, but my jobs were very structured. And so you were given tasks to do and maybe a feature to work on. I programmed tractors or problems to fix. There was very little creativity that I could put into play. And, we tell our students all the time, you work for a large company, you work for a small section of that product, and you do it a lot more times. Like for a small company, you would kind of be in on, designing it, testing it, marketing it, selling it, supporting it. Here, at a large company, work on one little spot and everybody else handles everything else. And so I didn't feel like I had much freedom there to try things, especially creativity wise. So here at KState, so much freedom, and some people don't like the freedom. Some people don't like the lack of structure that you would find in industry. And so there's so much freedom that I have. No one cares when I come to work. No one cares when I leave. But yet I have got a lot of responsibility to get stuff done. And that really fit me a lot better than working a certain time during the day and really not having the chance to dream and think up new things. And so this morning I worked on a new kind of a grad program for our department that probably never happened, but it was fun for me and kind of really good for me to think through that. And I like that. I like the design. I like I guess freedom to be creative is the biggest change for me. And it fits me. It's not any better than industry or worse. It's just, it fits me better than industry did. And so, with a small company, you probably have more freedom and a little less security, but a little more freedom to work on products and things and create.
So how do you think this applies to the future of robotics in agriculture? So are you working with startups or any industry on this, or are there other people who are doing this in this area? And what are the different roles that are being played out by the startups and industry and university and research settings of sort of kind of envisioning where we could be going in agriculture and sort of working on particular solutions?
Well, we are working with several startups. We are working with big industry as well. So several of the big industries had their own small robotic projects going on. Fint and AGCO, they had the Mars program. I hear that John Deere has one going on, but I can't confirm that. But we work with some small startups as far as there's a company in Topeka that's working with vineyards, and he's doing some fun stuff there with robotics and spraying. So there are it's a lot of roles going on, and kind of rethink what agriculture is with a whole new set of tools with automation and small robotics. And I think a lot of these ideas could be taken up and used in startups and things, and then it's like the electric car. People are getting more and more used to it, and so I see the same thing happening with ag robotics. Did that answer your question, or was there something?
Yeah, no, that's great. Thanks.
The only other question I had, and this may be similar to one that Scott asked a bit ago, but if you had a way of looking into the future, what comes after this kind of technology? Where is this technology leading agriculture overall? Let's assume that it's picked up and it's used, and what's coming next?
So if this was fully adopted and used, there'd be a lot more probably farmers at home keeping track of their robotics swarms, doing robotics and doing agriculture. One thing that I would love to see is that kind of a robotic farm, for university purposes. We proposed this a while back. It was called KS Utopia. I was very proud of that name, but it was just a piece of land that was fully run by robots and for farming. And I can kind of imagine a class where we teach a class and data would be coming in off this farm from these robots. And the students would take the data and analyze it and see what needs to be done. And maybe a student would be in charge of a certain plot of land, to control the robots and how to do the fertilizer and when to plant and keeping track of the soil. I see that as an amazing teaching tool for students in ag, automation. And, I could also see the downsides where we lose our farmers. And, would that happen? Would we have big, huge corporations that just run robots? I don't think so. I think there's always going to be farmers. Just like there's always the hobby farmers now. It doesn't make sense for them to be hobby farming, but they are because they love it. And so not a really good answer for that. I'm sorry, but
no, there was a fine answer. I guess as I've been listening to you talk over the last period of time, just thinking about the potential of multi-cropping in a field, or the potential of improving the environmental impact. And then you talked just a minute ago about these huge corporate-owned farms that may or may not be separate. That's the word I'm looking for, opposite of one another in their approach on things, but possibly could be. It's an interesting mix of potentials and possibilities that you've been describing that could come out of this. So I'm sure that some of this technology will be picked up. It's just going to be very, very fascinating to see where and how it's used most frequently.
Yeah, and I think there's a lot of government regulations coming down the road especially with pesticides and herbicides. And so I think we're gonna have to get creative with how we keep that yield up and how we make more yield to meet that 2050.
No, it's been great. It's fascinating stuff. It's just there's so much potential, and I'm excited to see what happens. Those other effects are dealt with, right? So we've got the positives, but then there'll be shifts. There'll be shifts in what's planted, right? There'll be shifts in in labor, right? Sort of you were mentioning labor was driving some of the technology, but then technology drives labor changes too, right? And so it's going to be so many differences. It does feel like I guess actually this is one of you've already said it, I guess, feels like a more substantial change than some of those other technology changes that you've described. And I wonder if you think it is just the next step in the chain of technological changes that have shifted farming, but it's not hasn't gone away, right? Or if it is something a little more substantial than what we've seen before.
Yeah, does it fall into the disruptive change category? Yeah.
Yeah, and I mean, as far as labor, We'll go away, with robotics, you won't need somebody to drive, a skilled laborer to drive the tractor, but you will need skilled laborers to run the robotics
Right.
and keep track of them and service them. And so
This has been fascinating. Thank you so much.
Yeah. Do you have anything for us, Dan, before we sign off here?
no, good luck. Thanks for what you're doing.
Well, I appreciate your time, and thanks, Scott, for coming on. And
Yep.
no, this was great.
Really exciting things. Thanks.
Thanks a bunch.
Bye-bye.
Bye-bye.
If you have any questions or comments you would like to share, check out our website at ksu.edu/research/global food and drop us an email. Our music was adapted from Wayne Gowen's album, Chronicles of Carmela. Special thanks to him for providing that to us. Something to Chew On is produced by the Office of Research Development at Kansas State University.